good morning. So in this lecture we will discuss the problem on least error square technique, which we have discussed in our last lecture. So now this is the data which has been given for you. See, consider a current signal having 50 Hz fundamental frequency and is sampled at 800 Hz sampling frequency. Calculate the phasor values of the DC components, the first or the fundamental components, third harmonic and fifth harmonic components from the sampled signal. So it means that the system is having a fundamental frequency of 50 Hz and the sampling frequency is 800 Hz, which means that you will be taking 16 samples per one single cycle. Okay, because n is equal to sampling frequency by fundamental frequency. It is 800 by 50, it is 60. 16 samples for one full cycle. And you are assuming that your signal consists of only these harmonic components, or maybe it is consisting of any other harmonics also, but you are more concerned about these components. So samples of one complete cycle have been given for you. 16 samples have been given for you. At each instant, these are the magnitudes which have been recorded. So you are now having 16 samples of data. And you need to determine these components. Which means that, see, since there are harmonics present in the sample signal other than DC components, so as already I told you, you are more concerned about DC components, first order harmonic, third order harmonic, fifth order harmonic. For DC component, I'll get only I0. So first harmonic, I'll get I1, this is I3, this is I5. So for these things, I'll be getting cos theta 1 and sin theta 1. This is I0, this is I1 theta 1, this is I3 theta 3. You need to determine these things, isn't it? So that's why I am resolving them into these components. So my X matrix will be having how many components? 7 components are there. 7 by 1. Okay. So now having said this, now see, as already I told you, based on the given data, fundamental and sample frequency of 50 Hz and 800 Hz. So my omega naught is 2 pi f naught, which is equal to 2 pi into 50. It is 314. And my sampling time is 1 by sampling frequency. It is 1 by 800. It is 0.00125. So, and my omega naught Ts, which I will be using frequently for calculation, this is 314 into this value. So using these values, you know the A matrix. This is your A matrix, right? So how many samples you need to take? You do have 16 samples. How many samples, minimum samples you need to take? As already I told you, it is 2H plus 1 is the minimum order. So now we have already seen that it is 7. So you need to take minimum 7 samples out of 16 for solving this problem. Okay. Right. So this is A matrix format. See, I have substituted omega is equal to 314 and Ts is 1 by 800. And this P I am taking up to 7. So 1, 2, 3, 4, 5, 6, 7 up to 7. So I am substituting these values of omega naught, Ts and P. So this is my A matrix. This is my 7 by 7 matrix. I have taken a minimum of only 7 samples. I have calculated it over computer. So these are 7 by 7 samples. Okay. Once I do get these things, you can it may employ this pseudo inverse technique, or you can directly, because this is my 7 by 7 matrix, so I can easily, if you see, I have taken only 7 by 7 matrix, so I can directly use inverse of this one. I have used MATLAB for this inverse. So this is my A matrix. So once I do have this, I can use this one, right? So this is my B matrix. I have taken 7 samples. So I'll show you. These were the samples. So I have taken the first 7 samples. 1, 2, 3, 4, 5, 6, 7 samples only I have taken. So yeah, this is my B matrix. So I have computed A and I have also computed B. So I have multiplied them. So this is my expression. So from the above data, what you can see is nothing but you can see that the magnitudes and phase angles can be computed using this one. So I can take it as I0 is equal to 1.94, isn't it? And similarly, what is my I1? I1, if I want to determine the magnitude, what I'll do is nothing but this is I1 cos theta 1 whole square plus I1 sin theta 1 whole square. I'll take square root of this. So what I should do, this is 9.305 square plus minus 3.917 whole square. So whatever the value which I'll be getting mod I1. So if you want to determine theta 1, what I should do, this is tan inverse of I0 sin theta 1 by I0 cos theta 1. So in this case, what is this one? This is tan inverse of I0 sin theta 1 is minus 3.917 by 9.305. You will get some value. So like this, I'll get I1 theta 1, I'll get I3. This is the magnitude, this is the angle. And I will also get, and the initial value I0 I already have obtained, it is 1.94. This is the way how you need to determine the harmonic components from your signals. So I have taken only 7 samples, but you can take all the entire 16 samples also, or more number of samples also, based upon your requirements. Okay, so for better efficiency, you better go with the higher number of samples. I have already given you how to determine the inverse also. Okay, so the conclusion of this one. The Fourier analysis is a special case of least squares. And the relationship between the least squares and the Fourier analysis, they are very close to each other. They suggest that there is a broad approximation algorithm between these two. The only difference is that the least square method can be employed when you do have a decaying DC component in your signal. Okay, and it gives a very stable results. The higher number of samples you take, the better will be your result, the accurate will be your results. But the complexity of the calculation also increases. But since modern computers, they can do these calculations within a fraction of seconds, you can employ them. You can employ more number of samples to get accurate results. Okay, so in the examination point of view also, I'll be giving you problems on this least error square method. But since determining 7 by 7 matrix inverse is also a difficult for you, so I'll be limiting myself only to 3 samples. I'll be asking you to determine the DC component and also the fundamental component. So which makes you 2H plus 1. So DC I won't be considering. So H is 1. So 2H plus 1 is 3. So 3 by 3 matrix you need to do in the examination. Okay. But for the problem's sake, take it as your tutorial. I hope that now you're okay with this least error square technique. You can apply this one. So as a tutorial point of view, you better consider 10 samples and try to solve this problem. Okay. So thank you. We'll meet again in the class and we'll discuss more number of problems. Thank you.